Another one of whether the molecules are the same or not. Okay, same enantiomers, diastereomers, are just plain different. Okay, so what is the relationship? So this one I want to approach slightly different. Okay, and so I'm going to show you something else that you can do in case you're not able to do it the other way. Okay, which means look at it from the sideways thing. So here is the molecule, which is CH3, Br, and then hydrogen in the plane. In the bottom one you have the fluorine coming out, hydrogen in the plane, and CH3 going behind. And here is another molecule where the CH3 is going behind, hydrogen is coming out, and then bromine is in the plane, fluorine is going to the back, hydrogen coming out, CH3 in the plane. Okay, so if you're asked to look at these two molecules and figure out what they are, then here's another thing you can do. Now, the reason I go the other way is because it's faster. Okay, this when you rotate any kind of a molecule, it takes a little bit longer time. All right, but I'm going to do that for you over here. So I'm going to take molecule, the first one, okay, molecule A, and this is B. So we'll work on A first. Okay, and I want to take the top carbon, okay, which is Br over here, CH3. And then we have the hydrogen, okay, over here. Now, technically speaking, your hydrogen should be at the back. So you want to rotate the molecule, okay, in order to get to the right kind of position, okay, orientation for you. So here's what we need to do, okay. We need to move the hydrogen to where the CH3 is. So which means the CH3 is going to move where Br is, and then the Br is going to move where the hydrogen is. Okay, those are the three rotations that need to occur. So hydrogen going to the back, the CH3 coming to where bromine is, which is to the front, and then the bromine is going where the hydrogen is, which is in the plane. Okay, that is what the rotation is over here. And this is Br. Okay, so this is what the rotation would look like. Now when you look at this, hydrogen is at the back. Okay, and it becomes a little bit easier for us to assign the configuration, okay, because now you can look at the bromine and say, okay, this is my second highest priority, and then this is my third one, okay, over here. So which means that this is S configuration, okay, over here. Now I'm going to do the same thing with the bottom one, okay. In the bottom case we have fluorine, hydrogen, and then CH3. To get the hydrogen to the back, you need to rotate hydrogen over here, which means that the CH3 will come where fluorine is, and fluorine will go where hydrogen is. So that's what we're going to do for the bottom carbon. And now our hydrogen is at the back. I always start with hydrogen because that's the lowest priority group. Okay, so hydrogen goes to the back. If it went to the back, the CH3 came to the front and my fluorine moved to the right. Okay, so again, you don't really need models for this. If you have a good sense of vision and 3D orientation, you really don't need models. Okay, you can work really very nicely with paper. Okay, all right, so then now we can assign priorities, and I'm sorry, this should be fluorine over here. Now we can assign priorities. Fluorine gets the highest one, and so now we just have to follow the arrow, okay, which is also S. Okay, all right, I'm going to do the same thing for molecule B. Okay, so which means I'm going to take the top carbon, rotate that one, and so on and so forth. Okay, so let's take that. We have bromine in the plane, the CH3 going to the back, and then the hydrogen coming to the front. Okay, I have to take my hydrogen to the back, so hydrogen goes to where CH3 is, CH3 goes where bromine is, and then bromine goes where hydrogen is. Okay, and so again start with hydrogen at the back. So then my CH3 moved to where the bromine is, and then the bromine moved to where the hydrogen is. Okay, and so here comes bromine. So my highest priority group is bromine, and then what is in the plane over here, and then this. Okay, so again this becomes S. I will do the same thing for my bottom carbon. So hydrogen coming out, fluorine to the back, and then CH3 here. Okay, now we can work this a little quicker because we know what we're doing. All right, and so hydrogen goes to fluorine, fluorine goes to methyl, methyl goes to hydrogen. Okay, so when you write this out, again, make sure you draw your hydrogen first. It is just easier to do. Okay, that's all. So if hydrogen is moving back, it bump off the fluorine. Fluorine comes right over here, and then the CH3 moves to where the hydrogen was initially, and so this is what we have now. Again, looking at the priority, then going this way, and we have S. So my first molecule here was S, and so is this and this, and so which means that the relationship between the two is they are same or identical. Okay, whatever you want to say, but that's what they are because they have exactly the same conformations. For the next problem, I want to take something different because we have, I think, done enough of the same and different kind of molecules. So I want to show you how you want to approach a problem in which you are supposed to write the proper stereochemistry of molecules. Okay, so this is also an important thing, drawing molecules in 3D structure. So you can see the molecule that's given to you, okay, which is really huge. So the first thing you do is identify the chiral center, which is over here. Okay, because this is the one that has 4 different groups on it. And so then you go ahead and assign priorities, okay, to your compound. And so nitrogen, which is the heaviest atom here, gets the highest priority. The next priority goes to the COOH group because that has 2 oxygens on it. And the next priority goes to the CH2 group over here, because this is attached to the phenyl group, which is many more carbons than the CH3 group. Okay, so the CH3 group is your lowest priority. Now this is actually quite easy to do because all you want to do is draw your carbon in the middle, draw your lowest priority at the back, okay, and then all you need to do is, if you have S conformation or R conformation, whatever it is, then you just go ABC or the reverse way. Okay, so in this case, let's go ahead and draw R conformation. Okay, so R, not conformation, R configuration, okay, of both of these molecules. So which means R, I should be going right, which means A, B, C. That's all I need to do for both of these molecules. So I start with my carbon, I put my CH3 at the back, and then I have my 4 groups that I need to draw out. My highest priority is the NH2, my next priority is carboxylic group, and then the next priority is the CH2 and this whole group. Okay, over here, no need to panic that you have this huge group, that is just decoration. Okay, so that's how you do it for this one. Let's look at the next one over here. Identify the chiral carbon, which is not this one, it is actually this one, the second one. So you put a star on that, and again you assign priorities. So again we have nitrogen, which gets the highest priority, and then the carbon over here is, when you open it up, it should have carbon, oxygen, oxygen, okay, and then another oxygen. So here carbon has 3 oxygens, and then on the left hand side you have carbon with a C, and an S, and here you have a carbon with an oxygen, oxygen, and oxygen. So the carboxylic acid gets the higher priority, so which means that this is B, this is C, and then hydrogen always is going to be D. So then we start with hydrogen going to the back. All right, you can never ever draw any kind of a stereoisomer without drawing the wedges and the dash line. Okay, so you must draw those out. Okay, so NH2, our second group is carboxylic group, okay, and the third group is this whole group over here. Okay, so make sure you draw the wedge lines and the dash lines to show stereochemistry, and these are both then R configurations.